In this video, we're going to create operators that shift a 2D field defined on a mesh of points in space to the east, to the west, to the north, and to the south. And we're going to create these shift operators in such a way that when we shift to the west, for example, things wrap around back on the eastern edge, and vice versa. When we shift one way, we wrap around on the other way. And it's also the same thing when we go off to the north, we come back in through the south. So it's doubly periodic both in the X, so it's like a cylinder that wraps around, so you can continuously go around, but also like a cylinder in the Y direction. So in fact, you can think of it as a torus, a donut. All right, the first step is to create the mesh of points. So we'll create a mesh of points, and we're going to define the size of our domain. So Lx is, let's say, 3, Ly is 2, Nx is 6, or maybe 5, and Ny is 3, 4. I want to have enough points that we can see what's going on, but not too many, so that it's hard to see what's going on. So 5 and 4 is a good number. All right, I'm going to use the Matlab's linspace to create these equally spaced points in both the X and the Y direction. So linspace X, 0 to Lx with Nx plus 1 points. And then I'm going to remove the last point. X is equal to X of 1, 2, and minus 1. And I do that because since the domain is, I want it to be periodic, I want Lx to be, the function to be periodic over Lx. So the point x equals Lx is really the same point as x equals 0. And so I don't save the repeated value in the X direction. I'll do the same thing in the Y direction. Oops. And just replace the X's by Y's. All right, the next step is to create a 2D mesh of points. So X, Y is equal to mesh grid X and Y. So these are all using these built-in Matlab functions. Let's see what that creates. I'll run it here. Let me put a semicolon to avoid that. All right, so I have X from 0 to 2.4. The next point would be at 3, but the point x equals 3 is really the same one as x equals 0 because my domain is periodic. And then Y, and then the mesh grid is a 2D array of these points. So Y has the Y values and X has the X values. One thing that's a little bit confusing, if you display the Y values in the terminal, in the workspace, you find that Y is increasing as you go downward on the screen. But if you contour it, so if I contour, C label, contour, X, Y, Y, over here, you can maybe, I don't know if you can see the font size is so small. Let's see, set GCA font size 16. You can see that in, oh, and then the other one, set, that this is the X direction, this is the Y direction, and so Y is increasing upwards, right? This is the contour 0.2, and up here 1.4. So when you contour it, Y increases upward on the screen, but if you display the Y at the terminal, Y at the terminal, it increases downwards. All right, now that we have our mesh of points, I'm going to create the shifting operators. And the way I'm going to do this is I'm going to first assign a unique index, integer index, to every point on the mesh. And I do this simply like this, defining I to be just x, but I'm going to replace all the values by a unique index from 1 to n, where n is equal to the number of mesh points in total, and x times ny, as follows. All right, let's run that. So now you see that the indices, every grid box on the mesh has a unique index. It starts in the southwestern corner, down here where there's a 1, and ends in the northeastern corner where there's a 20 in this case. So the mesh is a 4 by 5, so I have 20 mesh points. Okay, now to create the shifting operators, what I'm going to do is permute the rows of an identity matrix. So as you probably know, if I multiply a field by the identity or vector by the identity, it doesn't change anything. However, if I interchange or permute the rows, then it will permute the elements of the vector that the matrix multiplies by. And so I'm going to use that to permute the rows of the identity matrix in such a way that it returns the input vector but shifted either to the east, to the west, north, or south. So to do that, I need to do two things. First, I have to create a sparse identity matrix. So I is spy of n. So this is a sparse identity. Gyre I. So it's sparse in the sense that it only saves the non-zero elements. If I do full of I, you can see the full matrix. And you can see here it's an identity matrix with ones down the main diagonals and zeros elsewhere. But the I matrix doesn't store any of these, any of the non-zero elements. Any of the zero elements, I mean. Yeah. Okay, so now I have to create the shifting operators. I'm going to do this by simply shifting the II indices to the east, west, north, or south. And so that's straightforward to do by just taking, I east, by simply permuting the columns. So if I want to shift to the east, I interchange the order of the indices in the matrix. And I do it periodically. So if I want to point to the east, I go to grid point 2 and so on, the x index, and I shift it over. And then when I reach to the end and I have no more points on the eastern side, I just come back and grab the first column, and that's why I have the 1 at the beginning. And the west one will be similar, except that, I west, except now I will shift in the other direction. And then this is for the east-west shift operator. Now I'm going to create a similar one for the north-south. North and south. And if I want to shift in north-south direction, then I interchange, I use the first index, which is the north-south index. And I don't modify the second index. All right, let's see what these indices look like. Gyre. So this is the original index, and this is I east. So for example, if I pick the first point here, its neighbor to the east is grid point 5, and this is what is now stored at the location of the first index. If I pick this one, this one here, then its neighbor to the east is grid point 11, and so I get grid point 11 in the grid box that is indexed by 7. Same thing for I north. Let's put back the I. So if I pick this one here, the neighbor to the north is 1. Sorry, to the north is 3. Remember, these are listed in the opposite way. So if I'm in this one, the neighbor to the north is, if I pick this one, its neighbor to the north is 3, and I have 3 stored in the grid box. That is index number 2 in the original index. Okay, and now I'm going to use those to permute the rows and columns of the identity. No, not the rows and columns. I'm going to use these indices, these shift indices, to interchange the rows of the identity matrix. So I east is I east. I west is I. So let me show you what these look like. So I east is still a matrix with only 1s, but now the rows are interchanged so that, let me show you what it looks like. Full I east, for example. Now the 1s are no longer on the main diagonals. They're shifted in such a way that the 1 is going to be to pick up the element of the neighbor to the east, in this case for I east. All right, so to show you how this works, let's create a 2D field on the mesh and then shift it around, and so you can see how it works. So I'll create a function, f is equal to sine 2 star pi star y divided by ly. So it's a periodic function in the y direction. I also want it to be periodic in the x direction. So cosine of 2 star pi star x dash lx. So this is periodic in both the x and the y direction. And now I'm going to shift this field around and contour it on the screen. Shift it repeatedly. So my test function is going to be g, and I first initialize it using f, and then for I equals 1 to 1,000, or maybe 100 is enough, and I will say g is equal to I east times g. So every time I come into this loop, I take the original field g, I shift it to the east, and I stick it back in g. And then I make a contour of the result. So contour f, x, y, and g, color bar, set GCA, font size 18, and then draw now. And let's run it. Have to shift it down here. So you can kind of see that things are shifting westward. That's because I'm shifting I'm grabbing the neighbor to the east and plotting it centered. So that results in things going westward when I use the east shifting operator. So it's a little bit counterintuitive, but it makes it easier later on to use these shift operators to construct finite difference matrices, which is what we're going to use them for. So this was a little bit noisy because our mesh is very coarse. Let me add more points so you can really see what's going on. So I will pick 50 points and 40 points this time, so it'll be a little bit smoother. Close all, gyre. And now you can see the field shifting gradually, periodically, in the x direction. And we can do the same thing in the north. Now all I would do is replace the east shift operator by the north one. Close all, gyre. And now since I'm using to the north, things are shifting. It's as if I'm moving north. I'm traveling north looking down at the field, which is scrolling past me. You can think of that you're in an airplane looking down and you're flying over, and the landscape is flowing southward as you move northward. And you can do composition of these shifting operators. So if I want to move to if I want to travel in the northwestern direction, then I would also multiply by west. Alright, so let's try that. Close all, gyre. And now you can see we're traveling in the northwestward direction, and so the landscape is flowing down below us. Alright, so this concludes my lecture on creating shifting operators. In the next video, we're going to use them to create finite difference operators.